Hello, quick video on MEI C4 papers on and questions on planes. I've put two questions up here. There's a third one I'll come to at the end. But first one we typically see is around having 3 points that allows us to find the two in-plane vectors, which will be normal to the normal vector of a plane, and we're going to prove therefore that this is the normal through the scalar product. The other primary question is around the intersection of a line and a plane and angles between lines and planes. And the final one, which I haven't got here, is basically the angle between planes, which is the angle between the normals of planes. So I'm going to go through and demonstrate these two here quickly, and then you can then summarize where we are. Okay, so looking at the first question here, they've given us 3 points. Yeah, here they are, A, B, and C. And the first part, they ask us to find the vectors A, B, and AC. So they're asking us to find the in-plane vectors. So let's do that. Number 1. So the vector AB is therefore going to be the vector of B minus the vector of A, which is going to be B is -1, 2, -3, and then we're going to subtract the A vector, A3, 1, 3, -2, so we end up with a -2, -1, and then a -1. So that's our first in-plane vector, and our second in-plane vector is going to be AC, which is C minus A, which is 0, -8, +1, subtract 1, 3, -2. So my vector is going to be -1, -11, +3. So there's our first 2 marks. And the next part of our question says, show that the vector, here's our vector, is perpendicular to the plane ABC, and hence find the equation of the plane ABC. Okay, so if that vector is perpendicular to the plane, then it must be perpendicular to the vector AB, and it must be perpendicular to the vector AC, and therefore if we do the dot products of those vectors with this vector that they're giving us, both of those dot products should be 0, because the angles cos theta's really got to be 0 because the angle is 90. So let's put these up on the screen. So there's the vector that they're giving us, which of course we can rewrite in vector format as 2, -1, -3. And what we need to do is to show that the dot products with our in-plane vectors are 0. So I'm going to do AB dot, let's call that the normal vector, assuming it is the normal vector to our plane. That's what they've asked us to show. So that's -2, -1, -1, scalar product with 2, -1, and -3. So that's -4 from the first 2, +1 from the y's, +3 from the z's. That's 0, isn't it? And now let's do AC dot with n. So now I've got -1, -11, +3, dotted with the normal vector again, 2, -1, -3. So what have I got? My x, I get a -2. My y, I get a +11. My z, I get a -9. That lot equals 0. Yeah. Therefore, we've proved that the vector n is normal to AB and AC. Therefore, it's normal to the plane. Yep, normal to plane. Okay, final part they asked us to do was to find the equation of this plane, and we know it goes through all of those points, so I can just pick a point and make to find my constant. So I know at this point that given that this is my normal vector, here it is up here, which can do this in yellow, there it is there, that my equation of my plane must be 2x minus y minus 3z. Yeah, that's our 2 minus 1 minus 3 vector dotted with x, y, z vector. Now what I need to do is to find out what this constant is. I'm just going to pick the first point that we used here. My ABC is 1, 3 minus 2, so that must be true at 1, 3 minus 2, so I can substitute those in very quickly. Substitute those in. 2 times 1 minus 3 times, so 1 times 3, correction, minus 3 times minus 2, and that's going to equal C, so I know that's 2 minus 3 plus 6, which equals 8 minus 3 is 5, so C equals 5. Yep, so the equation of my plane is 2x minus y minus 3z equals 5. So that's the answer to the first question. Yep. Okay, let's go on and have a look at the second question. Okay, so in this question, they've asked us to find the point of intersection with the line. Here's our line equation, and the plane, here's our plane equation. Okay, so what do we do with this? Well, the point of intersection, the point R must satisfy both points. So what we're going to do is substitute our line equation into our plane equation. So here's our plane equation, 3y plus z equals 11. There we go, and we're going to substitute in our line equation. So the x value is minus 8 plus lambda times minus 3. Then we've got 3 lots of minus 2 plus 0 lambda to the 0. So that gets rid of that. And finally, z is 6 plus lambda to the 1, and that's all got to equal 11. So let's do some tidying up. I've got minus 16 minus 6 lambda plus 6 plus 6 plus lambda equals 11. Let me collect up all my unit terms here. I've got a minus 16, I've got a plus 12, so that's a minus 4. And here I've got a minus 5 lambda with that minus 6 lambda there. I've got an 11 on this side. Good, so where are we going next? So here I've got minus 5 lambda equals 15. So therefore lambda equals minus 3. Now I can substitute that back into my line equation, and I'm going to get, so here's my line equation I've just written. There we go, I need to put a lambda value in, so I'm going to put my minus 3 in for lambda. So what am I going to have? I'm going to have minus 8 plus 9, then I'm going to have minus 2 plus 0, and then I've got 6 and minus 3. So I've got 1, minus 2, 3. So that's my point of intersection. So let's go back and see what it asked us for the second half of this question. Part 2. Find the acute angle between the line and the normal. So we're interested from the line, we're interested in the line vector. And from the plane, we're interested in the plane vector. And if we want to find the acute angle, or the angle between those, we're going to use our dot product. So let's write that lot out a sec. So there are the two vectors. And what we're going to use these for? Well, we need to use our scalar product, that A dot B will be the modulus of A, B cos theta. So therefore cos theta is going to be equal to A dot B over the modulus of A times the modulus of B. So the top's going to be minus 301.2 minus 31. There we go. The bottom is going to be the square root of 3 squared plus 0 squared plus 1 squared multiplied by the modulus 2 squared plus 3 squared plus 1 squared. Here we go. So that's what we're going to calculate now. Let's do the top. The resultant of the x values is minus 6, of the y values is 0, and of the z values is 1. And then that's the denominator is going to be, the first bracket here is going to be 9 plus 1, so that's root 10. The second one is going to be 4 plus 9 plus 1, so that's 14. So that's minus 5 over root 140. If we put that in our calculator, given it's a negative number, it's going to give us an obtuse angle. It's going to be 115 degrees. So that's an obtuse angle because we had a negative cosine. So we need to find the acute angle. So if this angle here is 115 degrees, the other one, the acute angle, is going to be 180 minus that, which is going to be 65 degrees. That's for our acute. Yeah, 180 minus 115 degrees. Yeah. So that's the answer to our second question. So here's my quick summary. There's basically 3 types of questions they can ask you about planes. First one is to show that a normal vector that they give you is perpendicular to the in-plane vectors. So we're going to go through and use our scalar product, our dot product. We're going to find an in-plane vector by going from one point to another, and we're going to dot it with our normal and show that the result is 0. That's the first one. Secondly, they can find the intersection of a plane with a point with a line. Ask you to find the point, and if we know our line vector, we can substitute those values into our plane equation and find the value of lambda, and then substitute that back into our line equation to find the point. The third question that they can give you is to find the angle between 2 planes, where we're going to use our normal vectors, and we're going to use our dot product, our scalar product, by doing the scalar product here and finding our cosine of the angle. And remember to always look for the acute. That is less than 90 degrees. If you've got a negative cosine, then you've got your obtuse value and you've got to go for 180 minus. So there you go. Hope that's of use.